I want to start by saying that Alloy is a web-based application that is incredibly flexible, highly configurable, and it allows you to manage a very wide range of assets. So just to give you a quick view of that, currently we've got the carriageway asset displayed in there, but I could turn on car parks, commercial properties, grounds assets, tree assets, gullies. We could do street lighting. I'm not going to do all of them. Traffic signals, but you know, it could be more as well. It could be waste collection and so on and so forth. You know, the list keeps going on. The system is incredibly flexible, and you'll see a little bit of why it is as we sort of go through this presentation. When I say manage assets, I don't actually just mean holding the inventory records that you can sort of see in the map there. It's also about being able to record service requests against them, inquiries and defects. It's about being able to carry out planned and reactive activities like inspections and jobs, and have all of this supported by scheduling, by route planning, by highly configurable workflows, a mobile app that works online and offline, ensuring that your field operatives can will work efficiently and effectively without being limited by the technology. And Alloy can connect to a wide range of systems, sensors, controls and apps. It's been built for a modern world of IoT and smart cities, allowing for data to seamlessly move to where it's needed most. So if a sensor detects something or a member of the public reports something using an app, let's say, that information can flow into Alloy. It can either be manually handled or workflows can pick it up, create an action, and we can go and deal with it. And this kind of technology leads to a clearer and more timely view of your assets and your services and how they're performing. It allows you to react more efficiently to events as they occur, and ultimately it allows for you to deliver more informed decisions about how you manage your assets and deliver your services over the short, medium and long term. So, you know, today's presentation has an arboreal focus, so I'm going to turn off a few of these assets. I'd love to talk to you about all of them, but in 20 minutes that's going to be a bit of a push. So I'll leave a few on. There we go. So I've shown you lots and lots of assets displayed in a map, but we can also visualize individual assets or indeed activities or service information in lots and lots of different ways based on the information we hold in the system. So an example I'll give is we can see our trees here, our tree locations, but perhaps we want to view our trees in a different way. So what we could do is turn off the trees layer and maybe turn on the tree maturity layer. So this is all information that I hold against the tree asset, and I can see the styles here displaying the different tree statuses of maturity. It's all dynamic, so I can turn bits on and off. If I don't want to see certain tree types, I can do that. I can use kind of poly select features in the map to then draw polygons around them and edit them, or raise jobs inspections against them, and so on and so forth. So you know, really nice dynamic spatial visualization, filtering, querying and actioning. We can also view our assets in another way, so, or as many ways as you have data, essentially. So tree physiological condition instead. It's data that we hold against the tree. Let's visualize it. And again, all dynamic, so I can turn styles on and off. And that's really useful. That helps us to understand our tree assets more clearly visually in the map. As they say, a picture paints a thousand words. But actually, what's also really beneficial is seeing all these layers combined together. It can actually make them kind of greater than the sum of their parts. And I'm just going to nip to another location to sort of talk through an example of this. Oh, not that one. We'll go to this one. There we go. So, you know, it's really useful to know where your trees are relative to your gullies, and I know Mark sort of touched on this before, and you know, you also sort of touched on the fact that leaf fall can contribute to the blockage of gullies. So understanding their proximity can help us to better manage the situation. But the more information, the better, right? You know, it's useful having tree locations here and the gully locations, but if we're emptying the gullies, we can be capturing silt depths as part of that process. And if we have that information in Alloy, we can visualize it. So let's turn on the gully silt depth layer. And you can start to see where we've got blockages where we've got trees close to those blockages, you might capture other information about what is specifically contributing to that blockage, if it can be determined. And again, it's all just useful information to help us better understand the situation. We could also pull in more information, so maybe flood risk zones from the Environment Agency. So we've got your Zone 2 and your Zone 3 flood risk zones there. Again, it's all just about layering information together to see associations, to see trends and patterns, to build a clearer picture of the risk for a particular location, and correspondingly adapt gully emptying and tree pruning programs and regimes to mitigate against this risk. Now, I mean, if you took this situation in a siloed approach, if you took it on in a siloed approach and you adapted the gully emptying regimes without necessarily addressing the trees, or vice versa, you're not necessarily going to solve the problem as effectively. So bringing data sets together can be a really powerful way of improving the way you manage your assets.